Good afternoon, everyone. This is Qin. I'm a technical support engineer in Asia and Oceania Center of SuperMap. I'm glad here to give you a presentation regarding demonstration of SuperMap AI GIS technology. Before my demonstration, please allow me to briefly introduce the workflow of AI GIS based on the geospatial deep learning. As my colleague Jason has just introduced to you, there are three technologies in SuperMap. They are GeoAI, AI for GIS, and GIS for AI. In my section, I will focus on the GeoAI, which is based on the geospatial deep learning, and I will show how to realize the GeoAI with the whole complete workflow. So as we already know that geospatial deep learning is a method to analyze spatial data based on deep learning algorithms. SuperMap GIS and image data detection, classification, and extraction algorithms based on deep learning. And with the AI framework and the deep learning algorithms, we can achieve the object detection, binary classification, object extraction, and scene classification, and also the image or video object detection. All these models can be achieved for aspects. There are graph analysis, spatial temporal prediction, 3D data analysis, and image analysis. And in the next, I would like to emphasize on the image analysis, which with the functions of binary classification map of these GIS functions. What can we do with these functions? So as you can see that with the binary classification, we can do the building extraction or road extraction or any other objects you are interested in. And also the multiple classification are mainly used for the land use classification. Object detection, object extraction can be used for the airplanes, boats, or cars, or any other entities detections. And also the scene classification are mainly used for the classification of local climate regions. Let's take some examples. We have used this object detection to detect the palm trees for India, for Indonesian customers. They have amount of the UAV images, and they want to know how many palm trees they have. So, well, with the object detection, we can easily to get the result and get the count of the palm trees. And this is another application based on the binary classification. This one is for the Uzbekistan. They have different periods of images, and they want to know the building area change. So we can also exchange the buildings for different periods images, and then do the change analysis with this results. And this application is also for the Indonesia customers, and they have the images, so they want to get the classifications of this image images. They want to know the buildings area, road area, and the river area. So that's the result. And then let's go on the second part, which I would like to emphasize on this content. It is AI GIS workflow. As we know that the key process of deep learning is the learning process. So there are three steps to achieve the AI GIS classification or detection. Firstly, it is data acquisition and preparation. As we know that the deep learning is a learning process, so we need to connect amount of samples to train the data, and then finally to get a well-trained model for the final application. So these are the steps. The first one is data acquisition and preparation, and the second one is model building and management, and the third step is model publishing and application. And here I also want to introduce you which products SuperMap provides the AI GIS flow tool. The first one is the component GIS, which is SuperMap iObjects Python can provide the complete workflow of AI GIS. And the next is the desktop GIS, SuperMap iDesktop X. It provides the complete workflow of AI GIS as well. And also the server GIS, the first one is data science service, which also provides the complete workflow of AI GIS. And the last one is the machine learning service, which can only provide the model application service. Then I will briefly introduce each product. Firstly is the SuperMap iObjects. There are two parts, SuperMap iObjects for Spark and SuperMap iObjects Python. The SuperMap iObjects Python is responsible for deep learning related functions, just like the workflow of the machine learning, including the training, the data training, model training, and others. And the SuperMap iObjects for Spark is mainly responsible for the distributed machine learning. So this is for the component products, SuperMap iObjects. And the next one is the SuperMap iDesktop X, which provides all the complete workflow of AI GIS, sample generation, model training, and then application. And the last one is the SuperMap iServer. It has capabilities of distributed analyst service, machine learning service, and data science service. The distributed analysis includes distributed vector spatial analysis, related machine learning operators, distributed grid space analysis functions, and others. And the machine learning service focuses on the provision and display of spatial deep learning related capabilities, including publishing trained models into web services and providing AI GIS capabilities. And the data science service of SuperMap and the data science service of SuperMap, which we can see this detail, it provides the SuperMap iObjects and iClient Python libraries. In addition, the third-party libraries are built in. At the same time, SuperMap also provides the visual notebook editor interface for users to build operations of GeoAI. And this is an example of data science service which provides the whole workflow, including the data training, model training, and the application. And the next one is about the SuperMap iServer machine learning service. As I mentioned, that the SuperMap machine learning service can only can only used to referring or predicting. So how is to achieve the machine learning service? The first one, we should use the desktop X or other or objects or data science service to get a well-trained model and then publish the model to the iServer. Finally, the users can apply can use this model published on iServer to predict their images. And this is an example of application with machine learning, which achieves the binary classification, land classification, object detection, and other AI GIS functions. So here we can take a look at the complete detailed workflow of AI GIS. As we mentioned, I mentioned that the first step is data training. First, we need to connect the images data and vector data to get a standard trained data, and then this data, this standard training data are used for the model training. Finally, we get and the model and the training process is an iteration process. So the training the model can be got until the accuracy of which meets your requirements. So after we got a well-trained model, so we can use for the application, and further publish it to publish as machine learning service on iServer. And also SuperMap provides a series of post-processing. So we know that the image classification or extraction may contain many small misclassification or wrong wrong detection objects. So before we really use this results, we need to do some post-processing of the results. Then let's take a look at the first step, the data acquisition and preparation. We can here this is about the sample data. We can get the sample data from the common training data samples, just like the ImageNet or other public providers. Also, we can create samples based on our requirements. Just take this palm trees detection as an example. Here we prepare the image, and then we draw the bounding boxes of the palm trees using iDesktop. So these bounding boxes are samples for the further training. Let's take a look at the workflow of the data training. Also with the image data and the label data, also the samples. We are using the we use the training data tool, which we can use the SuperMap iServer or data science service or a desktop tools to get standard trained data. And the data can be divided into three parts. The one part is for training, and the second part is for the validation, and the third part is for testing. This is training data by SuperMap at Desktop X, and also this is data. This is code of SuperMap iServer data science service for the data training. And the second step is the model training. As I'm just mentioned about the three parts of the standard data set. One part is for training, and one part is for validation, and then the third part is for testing. So the whole progress is a iteration process. Also, after a long period training, and finally we can get a well-trained model with SDM format. And during and also we can use the iDesktop X or iServer data science service to achieve the model training. And during the model training period, the model needs to be verified again and again until meeting the requirements of the users. So just like this index, the accuracy index IOU, it is a value with the intersection error and the combined error. So we can get so we can validate the model with the IOU to test if the model is well trained. Besides, we also validate the model through the number of identified objects, such as the accuracy, or the recall, or the S1 code. as we know that the accuracy is a common indicator to validate the correct results. And the record shows how many examples are predicted correctly. But we know that it is hard to get high accuracy of the both. So if one score can combine the results of the accuracy and the recall. So finally, when we find that the model has reached the requirements of accuracy, so we can get a final well-trained model. And the last step is using the models to predict other images, which this part can achieved by using SuperMap at Desktop X, also the iServer data science service, and the iServer machine learning service. This is the application with SuperMap at Desktop X, and this is the interface of model application using machine learning service, which the result can be achieved by via the website. So after we get the final prediction results, we'll usually need to be further post-processing the results, just like this graph shows. While the middle of the picture is the extraction results, we can see that there are many abundant many misclassified or misidentified errors. So we need to remove these wrong errors and finally get better result to the further application. This video shows a complete process of the road extraction, which the steps from the data training and the model training and the road extraction by binary classification, and then the post processing to convert the final results, grid results to vector results, and then convert the result to a line vector. So here we are going to the last part. That's my demonstration. I'd like to show you how to exchange buildings using SuperMap at Desktop X. Here there are three data I prepared. The first one is building error. And the second one is labels, which are the contours of the buildings in this area. And then we are going to use these two images to get to train the data and finally get a well-trained model. Then finally we are using the well-trained model to predict the third image building. So now I'd like to go to the SuperMap at Desktop X. This is the SuperMap at Desktop X interface. Here we can see it provides many basic functions of GIS, and the tools are all for the spatial data processing. So here there are three data. The first one is this area, an image of this area, and then here I already add the labels of the buildings of this area. And the third data is the reference data. This data is we are going to use the training model to predict. So first thing, we should start a Python environment. As I have introduced that the AI GIS workflow, I will base the Python. So here we can see the Python is started. And then let's go to the toolbox and find the machine learning imagery analysis. Here we can see all these tools, including the data training, model training, and the applications, object detection, binary classification, multiple classification, string classification, and object extraction. This part I will use the binary classification to extract the buildings. Let's go to the first step. The first one is the data training. Here we just open the data training tool and select the sample image. It is the image and the samples, the vector, and also we can set the picture size of the standard training data. This parameters just indicates that why we need to generate training data. Because we know that the volume of remote sensing image data is large, and the CNN has high requirements for running memory. So the image needs to be processed into data suitable for machine learning model training first. So here we need to divide as simply simple extension that we should divide this the whole images into pieces, and the pieces is what we set the picture size. Here we all leave it as default, and then here the next we need to select the operators of the AI GIS, and here we select binary classification, and then here we need to set the output part. Here, let me new folder. New folder. And after we set all these parameters, here we can just run it. And the Python box will show the information of the process. you can check if it is running or if there is any errors. So here we get the results. The create training data have done. Let's go back to the folder to check the results. Here we can see there are 3 files generated. Here we can open the images. We can see that the images are divided into these images. And here we can check the information of the images, the detail. The resolution is 1024. So, and here also a map files related with the images. And then we get after we got this standard training data, we are going to the next step, the model training. So here we also need to set some parameters. The first one is the training data part. This one is the result of the first step. We select the whole folder, and then the training model uses we select the binary classification and the training config file. Here we are going to find the file under the resources folder. The binary classification training configure this one. The resources folder can be downloaded from our official website. And we select it. And the next, we need to set the number of training, the iteration time. The default one is 10. Actually, the model training is a learning. As we know that the model training is a learning process. So here, we need to set the iteration time based on the final accuracy. And here we all leave these parameters at default, and then set the log path and the model path. Then we can click here to run it. But here I want to do this because I emphasize that this is a long period process. So so here I only show how to set the parameters, and then the only one you need to do is click the run, click it, and it will run. And here we can, and in the Python box, it will show the model training details. And actually, I have got a well-trained model before our webinar. So here we will skip this step, and just take a look at the final result of the model training. So, as I mentioned that after the real training, the model trained, we will get a model with SDM format. And here we can see the descriptions of this model. And with this model, we can do the further application. So the next, I would like to show you how to use the model to exchange the buildings in this area. So we also send the boundary classification and data set, the source data set. We set the image we want to detect, and then set the model file. The building model, and then here we can just run it. We can check all the outputs and see if there is any error, and check if it is still running. So the boundary classification has done. So here we can see that we got a grid result. So we can open it. Close and next. So here we can see the result, and here is the result with this well-trained model, and here we can overlay the images. Also, I opened the wrong image. It is this one. And let's see transparency of the result. And also change the color of the result. So here, we already got the result. And then, as I mentioned, that after we got the result with the of the trained model, we need to do the further post-processing. Here, I just want to show you how to convert the grid data to vector data. As you know that the result is grid data. So here we are going to convert the data to the vector data. Here we are going to find spatial analysis and the raster analysis. Here is a function, vector raster data conversion, raster to vector. And here we just keep all this as default. And the dataset tab is the next region. And we run it. Here we finally get a result of conversion data and to current map. And here we also can check the attributes table. Here we can see the value includes 0 and 1. As I mentioned that the binary classification result is a grid with 2 values, 0, 1. The 1 represents the buildings and the 0 represents the others. So for the further application, so we can only keep the value with the value 0. That means we just need keep the buildings. We can make it this layer editable, and so we can just also we can open the we can check the 0 value of the results. There are many small pieces. So all these small pieces need us to process. Then like here this 0 value we can also delete it. So here we can finally get data set only with buildings, and then we can do the further processing of the other 0 value. And like this, and this we can delete or merge or do other process for this result data. So I think I have finished the all workflow of the building extraction using SuperMap at desktop X. I thank you for your listening, and have a good day. See you.